Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss a couple of common redo log file issues. So these are most kind of performance issues, and we are just discussing here because we are discussing redo and undo in detail. Okay, so the first thing that I had seen a lot of time in my in my database, which I'm installing at my home, that cannot allocate new log file. So a lot of times I'm getting this kind of error. Okay, so let's try to understand why we are getting this kind of error and what circumstances we are going to get, and then how we are going to solve this kind of problem. Okay, so before that, let's draw that diagram. No, so this is, so essentially this is the Oracle database on. Okay, so this is our buffer cache, and then this is our redo log, and then what we have data file and also this online redo. So let's write it down. So this is my buffer cache, and this is your redo buffer, and this is my online redo, and this is my data files. Okay, so let's say we are in a system where we are doing and then also understand that online redo is of that they generally come with a pair. That means it should be, so let's just remove this thing. So what I'm saying, the online redo log file will come in pair. So this is, so let's say there's two pairs, right? So two files, and just write down file 1 and file 2. So let's say we are doing a lot of insert, update, delete, a lot of transactions are going on. So therefore we are filling this buffer cache, making it dirty, and at the same time we are writing to the the redo information into the redo buffer, and we're keeping. Eventually what's going to happen, lgwr, which is log writer, lgwr is going to write to the file f1 either in 3 seconds or whenever somebody does a commit, or 1/3 when this thing is 1/3 filled. Okay, so let's say we are doing a lot of lgwr writing, and then we are also filling this one. So a lot of transactions going on, buffer cache modified, redo buffer created, and lg writer is writing to these files. So eventually this file f1 is going to be filled. When f1 is going to fill, then log switch is going to happen, and then lg writer, instead of writing to, so let's this line will no more there. So instead of writing to file 1, lg writer is going to start writing to the file 2. And still there is db writer is there, but db writer is not doing anything because it's still it's going on. Okay, db writer is not into picture right now, and eventually this log writer is going to, okay, it's going to fill, and just about to fill, db writers somebody makes a checkpoint, and db writer is starts to writing now. Okay, so db writer is about to write right now. Okay, so db writer starts, but before db writer finishes writing all this dirty buffer, let's say this file f2 is completely filled. If file f2 is completely filled, then log writer is trying to switch to file f1. Okay, so in this case, so log writer is basically in the process of switching to file f1. But notice that whatever there in f1, right, there's no guarantee that because db writer has not completed yet, right? So as you know, the whole purpose of online redo is to make sure that if database in the instant crashes, we can recover. So notice that we might not we might not have completely write this db writer. Db writer might not have completely write all those buffer cache. If we want to overwrite here, okay, so let's say we are allowed to do overwriting, and we are allowed to do overwriting, and we had overwritten couple of log writer overwritten couple of this thing. Let's say assume that at this point db writer just written couple of things is not complete, and then the instant crashed. If the instant crash means this thing is all gone, then there might be a case that DB writer has not completed, and also log writer in the old value, right? Whatever the old value, those things are not being reflected here in data file right now. Therefore, if we allowed to write, then in this scenario, if this crash, then we might lose some important transactions. Okay, because we are already overwriting. So therefore, in this case, we are not, log writer is not going to allowed to write. Okay, so that is the point when it will give you an error saying that cannot allocate new log. Okay, so now, so this is a problem, right? And then you see a lot of times you see this kind of thing, cannot allocate new log, and after that what is going to happen, checkpoint is going to happen. So in that case, the first thing is that no transaction is going to be, the Oracle database is not going to respond anymore to anything until and unless all this data, right? So basically in normal case, LGWR is going to still pointing to this F2. The LG writer is going to point to F2. The first thing is going to happen, let the DB writer finishes all this thing. So when DB writer is going to finish all, flushing all the buffer, dirty buffer to the data files, so at that point we can, overwrite, not a problem, because we have already written, whatever this thing, we do not need anymore this data to protect, because we already, those things are in our data file. So that means the first thing is going to do, whenever you're going to give this cannot allocate new log, and then it will start a checkpoint, so that DB writer is going to write, and after that, once this checkpoint is done, then in this this F1 is going to be allocated to LGWR. So now log writer is going to start overwriting on file 1. So this is how we are going to get rid of this problem. But remember that until this thing happen, database is, nobody is going to do, no one is allowed to do any more transaction. That is bad. Okay, so that means as a DBA, when you are seeing this kind of error, you try to make a preventive measure so that you are not going to see this kind of problem anymore. So what is the solution? The solution is, try to make checkpoint frequently. If you make checkpoint frequently, then that, basically while this, while maybe if you are writing this into this log file, so while data is written to this log file, maybe you can do a checkpoint, and then you write from DB writer to here, and but it will not going to potentially, it's not, it's always a probability, right? It's not going to completely get rid of your problem. Okay, then number 2 is get faster DB writer. That means if you can write this thing fast, right, by using multiple slaves and all this thing, because DB writer is just collect this thing and give it to slaves, right? So use more number of slaves so that DB writer can give them and then go back and then try to collect the other things. Okay, so get faster, implement some kind of faster DB writer mechanism by using more number of slaves or even faster disk so that you can write it faster. And number 3 is maybe you can think of increasing the size of log file, increasing size of redo. By increasing size of redo, it will basically this will not again eliminate the problem, but this will take some more time. It's less frequent you are going to see this kind of error. Okay, but eventually DB writer, even DB writer is a lazy writer, but DB writer is eventually is going to wake up and write it. Okay, so if you have a bigger log file, then it may say you may not see that frequently this kind of issues. Okay, so this is the problem, and this is a solution that cannot allocate new log. Another kind of problem that I have seen is that whenever you run this thing, there is a if you run this AWR or StatsPack. So this is the statistics that I collect, how my database is running and all. There is a important matrix, and that matrix is called log file sync. So whenever you are looking for your AWR report or StatsPack report, whenever you run this thing, look for this thing called log file sync. If most of the time you see these things all fine, but if you see this log file sync weight, this is a high number. Okay, If this is a high number, then that is something else is going on. Okay, so that means if you get a high number, you should not see that log file syncs to be very high. If it's very high, then probably you are experiencing log contention. Okay, so that means when you are going to experience log contention, let's say assume that in this system you are doing a transaction, that transaction doing a lot of commit. Remember that log writer is going to write whenever there is a commit. Let's say I'm doing 10 commits in 1 second. If I'm doing 10 commits in 1 second, it may happen that there's only one log writer, right? So unlike DB writer or slaves, you just have only one log writer, right? So one log writer is going to write, and then every like the way that you are doing commit in every 10 second, because log writer is going to write whenever we're doing a commit, or whenever doing a every 3 seconds or so on. So therefore it may happen that log writer is in contention, like there are a lot of commits are going to happen. So in 1 second is going to write 10 times. Okay, and that means you are basically blocking on log writer. Okay, so this is one of the problem. So how to solve this thing, right? So to solve this thing, basically you make your whenever you are commit, like a lot of people think that if I do commit frequently, I'll be doing the things better. But that, as you know, like in a couple of videos before, we said that like even if you are doing a 10 row insert or 1000 row insert, doesn't matter, commit will be always constant, the commit time is always flat. Okay, so therefore a lot of time developer used to be in this doubt that if they commit more frequently, it will better. But I think you are making it worse. Okay, so if you commit more frequently than is required, you are making it worse. So basically, as I told you, the golden rule of committing is make a logical unit. Whenever you think that this is the time that I need to commit, just go for it. It's not necessary to go for a for loop and commit for each after each insert. So you can basically design an application which is going to try to basically do less commit. And also from system point of view, there are a couple of things you can take. Like you can, like maybe you have a so slow disk device. Okay, so that is why in the first place log writer is taking so much time to write. Okay, so basically you might have a use a faster device. Okay, and then so a lot of time so a lot of time basically all these log contention errors are attributed because you are putting the redo log file and data file on the same device, on the same physical disk. So if you are putting in the same physical disk, then DB writer is going to write, and the redo log write LGWR is going to write to that thing. Okay, so that is again another point of contention. So try to separate redo log file from data file. So from the disk from data file, try to have separate disks for redo log file and data file. And number three is a lot of times you make a mistake. Like let's say you are doing in a cooked file system. That means like remember, like some videos back we discussed about different types of file system, like cooked file system, raw file system, clustered file system, and so on. So in case of if you are using cooked file system, so essentially what you do whenever log writer or DB writer they write, they give this by using fwrite or those kind of things, you give it to the operating system to write. Okay, so now again, like remember, operating system kernel is going to this data is going to buffered at the operating system kernel, and operating system kernel is going to write to the redo and to the data file. Again another point of contention, that you are going to depend on OS kernel. Okay, instead of that, what you can do, you can do a direct IO. So make log writer directly to talk to the disk drive. Okay, do not go through another intermediary called operating system. Okay, so do basically unbuffered write, so that will make your thing faster. And so this is what is a common kind of issues that you can take care from the system point of view to avoid this log file sync issues. And what Oracle suggest you is suggest you a optimal redo, basically optimal in case of just for optimal performance. Okay, so what they recommend, you use 6 disk drives. Okay, so for redo you use 6 disk drives, out of which 4 are small. Remember, I do not really need a big I do not really need a big disk for this redo, because redo just only contain how much, like it just contain only very less amount of data, right? So it's instead of buying a huge disk, buy small disk which is faster. Okay, faster and smaller disks. So the way that you are going to use this redo, you use you have 6 disks. Let's say this is called disk 1, and then we have, so let's put in some different color because there is a reason behind that. So let's make this is my disk 2, and then what I'm going to have this is my disk 3, and then this is my disk 4, and then I will have another disk is 5, and this is a little bigger. Okay, so what I'm going to do here is, like 1 and 2, this will be configured in a group. That means when log writer is going to write, to disk 1, at the same time the same information is written to disk 3. Okay, so this is called a disk group. Okay, so this is your disk group 1, and this is your disk group 2, so dg2, and this is your disk group 3. Okay, so lgwr is going to write here. So while lgwr writing, so let's say this is going to fail eventually, and then this is a mirror, right? You remember why you do a mirror, because redo is one of the most important thing in the database. We can never afford to lose any redo log file. So the reason behind having this thing in making basically writing to in a mirror way is that if I'm going to lose this one, then I'm always going to have this one. Okay, so therefore log writer is going to write in a write 2 times at 2 different disks. So this is the 1 and 3. So once 1 and 3 eventually failed, then log writer is going to switch to 2 and 4. So log writer is no more is going to be here. So this is completely filled right now, and then log writer is make a switch to log writer is now writing in 2 and 4, and it's going to write. So while log writer is writing on 2 and 4, what you can do, your archive log file arch, remember that archive log file, you can start archiving this information, right, to your archived redo log. So this is basically, that's the yellow ones are archived redo. So what's going to happen? So whenever log writer is busy in writing the second disk group, you archive from the disk group 1. So therefore, so now this is dotted line, so this is being archived to, so archiver is basically trying to archive to disk number 1 to 5, disk number 3 to 6. And once this archive is done, and like once this and at the same time log writer is also going to complete writing 2 and 4, and then log writer is going to switch to disk group 1. And then if you are using because this 1 2 3 4 is to be slower disks, sorry, faster disks, but of small size, whereas this archive log file should be basically faster, it need not be faster, but it should be up, the size should be much more than whatever it is. So that means using 6 disk you can optimally make a redo. Okay, so the optimal redo, and then in that case you probably avoid all these issues of log file syncs to be very high.